లేదు సేఫ్టీ కోసం ఒకవేళ టైం పర్మిట్ చేస్తే డిస్కస్ చేద్దాం తెచ్చుకుంటాం. Okay. Hello my dear friends, good evening to all of you. According to the today's schedule, we are going to start environmental engineering subject according to our score booster series, right? Okay, before starting this session, let me have a small talk with you regarding this environmental engineering subject, right? You all know this is the highest weighted subject after your geotechnical engineering, right? Let me take a small slide here. See, I am trying to convey one important point about this environmental engineering subject. Let me take these 4 chapters mentioned in your syllabus. If you can look at these 4 chapters, you can definitely get some questions in these chapters. These are very important chapters in the entire environmental engineering. I am not saying rest of the chapters are unimportant, but surely you will get some questions in these chapters. You can look at the air pollution, definitely you will get 2 marks, and solid waste management 2 marks, and I am combining these two. I am not sure about in which chapter they may ask the question, but both the quality of water and quality of wastewater are very important. I am just taking the lower side, I am taking 2 marks, right? See, out of the entire environmental engineering, you are getting approximately 6 marks from these chapters, right? You will get around 5 to 6. I am taking the lower side, okay? 5 to 6 marks are exclusively from these chapters. The rest of this syllabus, you will get the remaining weightage, right? If you can think the weightage, you already know you will get 12 to 14 marks from the environmental engineering. Out of this, 50% weightage is given to these 4 subjects. Definitely you will get the question from air pollution, solid waste management, and out of these 2, you will get any of the chapter, you will get 2 to 3 marks, right? I am taking the lower side, 5 marks guarantee, right, from these chapters. My point is, please pay enough attention to these chapters, then rest of the syllabus is also important. Entire environmental engineering syllabus is very important since it is highest weighted subject, right? This is my point now. Okay, without any delay, let's start the session with solving NAT and MSQ, right? Okay, please go through this question, my dear friends. It's a very easy question, NAT. Look at this question. Cooling tower blowdown from a power plant is discharged to a surface stream. The characteristics of each are given as stream characteristics are given as well as cooling water characteristics are given. What is happening here? Once the power plant cooling system has blowdown and the discharge is added to surface water stream, right? When this cooling water is added to surface water stream, what is asking? Assume that the cooling water mixes instantaneously with the stream. The acceptable limit of chromium in drinking water as per the IS code is 0.05 milligram per liter. This is an acceptable limit. He has already given. Considering the public health risk associated with chromium, the efficiency of the ion exchanger required for the effective chromium removal is dash in percentage, correct up to 2 decimal places. How to approach to this kind of question? What is happening, my dear? If you can look at this scenario, I can express my thing easily through some small animation. Look at this. This is the flowing river. It is having some stream flow, and suddenly what happened? Power plant cooling system has blown down. Suddenly at some point this discharge, cooling water flow is added to the flowing stream. What is this point called? This point is called point of disposal. This is a well known fact to all of you, right? At that point of disposal, we can say theoretically we have upstream and downstream points, right? If you can look at this, he has mentioned this cooling water having the chromium concentration is 0.9 and also the stream having chromium concentration as 0. Chromium is a heavy metal. The stream, surface water stream, natural stream may not have this chromium concentration. What happens when the moment this cooling water mixes to this flowing stream, the instantaneous mixing, he said, then here you can experience instantaneous mix. You will get the mix concentration of chromium here, neither 0 nor 0.9. You will get the mix concentration in the downstream side. What is the mix concentration? First evaluate. C mix equal to, you have stream discharge and chromium concentration in the stream, plus you have cooling water discharge is QC and chromium concentration in cooling water is CC, divided by total discharge is stream discharge plus cooling water discharge. If you can look at the stream having 0 chromium, therefore I can eliminate this word, right? It is 0. Now you can get QC. What is QC? Discharge of cooling water is, he has mentioned 40 meter cube per minute. I convert into, he has given 40 meter cube per minute. You convert this into second, 40 by 60 means 2/3, right? Therefore 0.667 is the discharge of cooling water, in which the concentration is 0.9 divided by the stream discharge is given as 10. Go back to that slide. If you can go back to that slide, stream discharge is 10 and cooling water discharge is 0.667. If you evaluate, you will get the C mix value, right? Let's check what is the value you are getting. 0.667 into 0.9 divided by 10.667, right? You will get 0.0562 milligram per liter chromium you will get at the downstream side. This is C mix concentration, but chromium has a health concern, right? We will get a cancer risk of chromium. To that, we needs to treat this water before supplying to the community. What is the drinking water standard? He has mentioned C standard, chromium standard. I am writing in small words. C standard is 0.05 milligram per liter. Do you need any treatment here? Obviously, it is a carcinogenic in nature. Even the small concentration may leads to cancer risk for prolonged exposure, right? You must treat the C mix concentration, bring it down to standard value. Allowable value is 0.05, right? Therefore, what is the efficiency required? Let me take the efficiency of ion exchanger, right? Efficiency is what? Initially you have in the stream C mix, but standard is allowing you to 0.05. You need to compare with the initial value. That is what? Efficiency of treatment needed. What is C mix? 0.0562. 0.0562 minus 0.05 divided by 0.0562 multiply with 100 will give you concentration, efficiency, right? What is the efficiency you are getting? 0.0562 minus 0.05 divided by 0.0562 will give you 11.03, right? This is, let me check once again, 0.0562 minus 0.05 divided by 0.0562 will give you 11.03%. Up to 2 decimal places you will be given a range. Don't worry, if your answer may deviate little bit, please don't worry. You need to enter 11.03 as your answer. Range will be given, your answer will be taken care by the range, right? Okay, this is what the important question. The most important thing here, he has mentioned this instantaneous mixing, so that after the disposal you will have the C mix concentration of chromium. Then with the help of C mix, you just bring it down to standard value. That is what treatment, right? Whatever the chemical concentration you are having, bring it down to standard value. What efficiency is asking, that is what we evaluated, 11.03%. Let me see how many of you are answered to this question. Okay, let's move on to the next. Okay, look at this. This is the important question. The beauty of the environmental engineering subject is, if you do not know any specific concept in environmental engineering, still you can answer by playing with the units. That is the beauty. Look at this question. the height of an ion exchanger required to treat 1 mld of water using an exchanger of capacity is given 90 kg per day per meter cube with a rate of flow of 4.4 meter cube per minute per meter square is dash. What he is exactly asking? The height of ion exchanger is what? In meters he is asking. Please be careful in which units he is expecting your answer while solving NAT. Very important tip. You need to look at this first. In which units he is expecting your answer. With the virtual keypad you need to enter some value, numerical value, but units you must be very careful before answering this question. Okay, he is expecting in meters height. If TH, total hardness of water, is 150 milligram per liter as CaCO3, how to proceed with this question? Let's take this question. See, with the help of TH, what ion exchanger do? Ion exchanger reduces hardness from water, right? What is the concentration of hardness given? Let me take this with the TH concentration. What is TH concentration? What is the TH concentration given? Concentration given as 150 milligram per liter. This is the concentration, but I need total TH present in the water. What is the quantity we are treating? The Q value. Q value is 1 mld. 1 mld is the capacity, right? This is what ion exchanger required to treat 1 mld of water using exchanger of capacity is given, right? This 1 mld needs to be treated, right? This is the concentration. What is total hardness? You can say this is the concentration given. I am converting into hardness. Total will give you Q multiplied with concentration, right? Concentration is 150. You know very well this fact. If you multiply mld with milligram per liter, you will get kg per day, right? 150 kg per day, right? This is the well known fact to all of you. mld into milligram per liter is kg per day. Now look at the units provided in the question. Be careful. See, ion exchanger of capacity 90 kg per day per meter cube. What is the unit he has given? 1 meter cube of exchanger capacity can control 90 kg per day of the total hardness, but I needs to treat 150 kg per day. How much volume I need? Easily you can get, right? What is the volume of exchanger I need? Look at the volume. I am started evaluating the volume of exchanger with the help of the given point. What is the capacity? 90 kg per day per meter cube. We are having 150 kg. Therefore, we need to clear 150 kg per day of total hardness load from water. But capacitor having the capacity of 90 kg per day per meter cube. Per day per meter cube will give you volume only. This is what I needs to treat, kg per day, right? If you do this, you will get the volume. Volume you will get is 3 5s 15, 5 by 3. 5 by 3 is 2 point. Use the virtual calculator for gate, okay? Don't worry. 1.667 you will get. Volume is 1.667 meter cube. I found out volume of exchanger here, but he is asking the height of ion exchanger required in meter. Can we get a area from any of the data given? If you can look at rate of water flow, rate of flow is given as 0.4 meter cube per minute per meter square. If you convert this mld into meter cube per minute, and we have this rate of flow per surface area, you will get the area. Now I am evaluating the area. Area is equal to area. How to evaluate area? 1 mld I am converting. 1 mld means 10 to the power of 6 liters into minus 3, 10 to the power of 10 cube meter cube per day. Meter cube per day 24 into 60 will give you meter cube per minute. I converted just 1 mld into meter cube per minute divided by this meter cube per minute per meter square will give you area. 0.4 divided by 0.4 will give you area meter square directly, right? Now let the 24 into 60 into 0.4 inverse into 1000 will give you 1.6 7361 meter square. Now I am having volume, I am having area. Can't you find height? Very easy, right? Height equal to height of the exchanger required equal to volume of the exchanger by surface area of the exchanger. What is the volume? 1.667. 1.667 divided by area 1.7361. This is the surface area. You will get approximately 0.67. 1.73 is the area into 1.667. It will give you 0.96 meters. This is the height of exchanger needed, right? Very easy. If you can understand the units, you can play with the units and you can attempt the question. Let's see how many of you are attempting. Okay, moving on to the next question. Look at this. This question is the MSQ question. The surface overflow rate in a rectangular sedimentation tank is given as 45 meter square day. Minimum dia of spherical inorganic and organic particles expected to be completely removed in a tank are calculated. Assume that Stokes' law is applicable. Which of the following options are correct? He has mentioned SOR, surface overflow rate, that is 45 meter per day. Convert that into meter per second also, right? Now he mentioned inorganic specific gravity, organic specific gravity and G value and kinematic viscosity, known data. Now you need to verify what is the minimum size of inorganic, what is the minimum size of organic particle. Let's take the data given 45 meter cube per day, right? Meter cube per day per meter square. Now what is SOR? Surface overflow rate, also overflow velocity V0. V0 is equal to 45 meter cube per meter square per day, means meter per day. I converted into meter per second, 86,400 will give you the velocity V0 in meter per second. 45 divided by 86,400 will give 5.2083 into 10 to the power of minus 4 meter per second. This is what SOR value. He has mentioned to completely remove organic and inorganic particle. What is for 100% removal? For 100% removal, what is the criteria? For 100% removal, V0 must be less than or equal to settling velocity. At equilibrium, V0 is Vs. You know, according to the Stokes' law, what is Vs? Vs is equal to Gd square into S minus 1 specific gravity by 18 nu kinematic viscosity. You know, value of G 9.81. Diameter of inorganic I am estimating first, Di square inorganic. What is the inorganic particles specific gravity is 2.65, right? 2.65 minus 1 divided by 18 into 10 to the power of minus 6 is the kinematic viscosity. But this settling velocity, which is almost equal at equilibrium, V0. What is V0? 5.2083 into 10 to the power of minus 4, right? This is what value. If you evaluate, you will get the Di value some 24 microns. Let me check. This is the value into 18 E minus 6 divided by 9.81 into 1.65 under root. The answer will give you some 2.4 into 10 to the power minus 5 meters. You will get convert into multiply 10 to the power of 6 will give you 24 micrometers is the diameter of the inorganic particle. Similarly, you can estimate organic particle by considering this equation, right? I am now considering organic. 9.81 into organic particle is diameter is this. What is the gravity, specific gravity of the organic particle? 1.2. Therefore, 1.20 minus 1 divided by 18 times kinematic viscosity is 10 to the power of minus 6, which is also equal to V naught, 2083 into 10 to the power of minus 4. You will get the answer as 5.2083 into 18 divided by 9.81. Please solve. 1.20 under root answer will give you, let me check, 5.2083 into 18 divided by 9.81 into 0.20, sorry, 0.20 you need to take. You will get 69 microns, right? Organic particle of diameters you will get multiplied 10 to the power of 6. 69 micrometer is the organic particle of size, right? For complete removal, this is the values. What are the options here? Inorganic is 24, organic is 69. Options are A, comma B. Multiple select question. If you miss any of the option, gone. Okay. Please be careful with MSQ. If you attempt all the 4, question gone. Whichever options are correct, you need to identify all the correct options. Okay. Next, look at this question. For a water, the chlorine dosage at a break point is 1.8 and the residual chlorine at the break point was found to be 0.4. At the residual chlorine at the break point is 0.4. Then the residual chlorine, if 3 milligram per liter of cumulative chlorine added is dash. What is asking? The residual chlorine, if you add 3 milligram per liter as cumulative chlorine dose. You can understand this if you draw the curve, right? You know, this is a well known chlorine demand plot, right? This is the dose versus chlorine dose versus residual chlorine, right? Residual chlorine, right? This is the dose. Dose means Cl2 dose. If you can look at, I am just ignoring iron and manganese reducing substances. You can start with the origin also for namesake, and the curve like after the break point like this, right? This is indicated as break point B. What is the break point dose he has mentioned? He has mentioned break point is 1.8 where that residual chlorine is 0.4. At break point of 1.8 residual chlorine is 0.4. Therefore, this is 1.8 milligram per liter where the residual chlorine is, this value is what? This is the residual chlorine, right? 0.4 milligram per liter. What is happening? I am adding chlorine dose after the break point. Whatever the amount you are adding after the break point, it appears as residual chlorine. If I add 1.8, 1.9 means 0.1 milligram, it appears as a residual chlorine. What happens is, after the break point, we assume this curve is perfectly straight line. It means this angle is 45 degree, right? What is the cumulative dose he has added? 3 milligram per liter. Cumulative means cumulative 0 to 1.8, 3 means what is the gap? This gap is 1.2 milligram per liter, which means this is 1.2 milligram per liter. This one is already known. This is combinedly available chlorine is 0.4 milligram per liter. After the break point, what is the additional dose we have added? That is 1.2. If this is 1.2, if this is 1.2, you can see this is also 1.2. No need of circus, tan 45 opposite side by adjacent side. 45 means this line length same. Therefore, if this is 1.2, this is also 1.2 milligram per liter. But he is asking after cumulative dose of 3 milligram per liter, what is the total residual chlorine? This is the total residual chlorine, right? What is this total? 1.2 plus 0.4 is 1.6 milligram per liter. This is the total dose, right? The answer is, you needs to enter 1.6 milligram per liter. Answer up to 1 decimal place. You are getting 1.6 exactly. These kind of answers, you are nowhere getting some decimal values, right? Exactly you are getting 1.2, 0.4, 1.6. They'll give 1.6 as your answer. They don't give any range, since you are getting the answer exactly, right? Be careful with this numerical answer type. Okay. Don't underestimate this question. Even they asked for a QC, there is a chance that you may this orientation of the flow, if you miss any orientation in a different way, you may end up with the wrong answer. Be careful. What he is asking, a pipe network for a water distribution system is shown in the figure. The discharge in the sum of the pipes and junctions are shown. At some junctions and some pipes, discharge is given. You need to estimate the discharge in this pipe QC marked, right? Discharge QC as marked in the figure is how much. For this, I am considering the whatever the network he has mentioned in the given question, I am taking that network into consideration. You must be very careful while analyzing this. This question is very easy, but you may answer it in different way if you miss any orientation of the pipe flow, any orientation of the discharge. Look at this. This is like a analysis of trusses, each joint and joint by joint, how you are evaluating forces at particular joint. You can simply do that, right? Let me take at joint D. Look at the joint D. At joint D, look at the 80 units is entering and 30 units is leaving. What is another pipe at joint D? This pipe. What is the flow in that pipe? 80 is entering, 30 is leaving. What is the balance? Balance is 50 units. This is 50, right? At D, we analyzed inflow, outflow same. 80 is inflow, outflow is 30, 50, 80. Now, moving on to the next node or next junction, here 30 is coming, here 20 is coming. What is the total coming into joint A? 50. What is leaving? 40 is leaving, balance 10 goes to this pipe. This is what? 10 meter cube, 10 units, not mentioned meter cube or anything, units. Now, moving on to the node B. Already here 40 is coming, 25 is leaving. What is the balance? Balance will moving on to this pipe. What is the balance? Balance is 15 units. Now look at the node at C, at this node. What is happening? 50 units is coming, 10 units is coming, 15 units is coming. What is the total discharge at QC? 50, 10, 60, 10, 75, right? QC is 75. Be careful while analyzing the network, right? This is what? Answer 75. Exactly you need to enter 75 as your answer. Okay, this is what you need to attempt. Let me see how many of you are putting the answers. Okay, please involve, please start solving, right? Okay, the next one, very easy question. Okay, look at this. This is a very important area in the air pollution. Maybe this time you may expect a question on the air quality index, right? Look at the statements given. With reference to the AQI used in India, which of the following statements is or are correct? Look at the statement 1. AQI in India is calculated only if data for a minimum of 3 pollutants are available, minimum 3 available, one of which must be either PM 2.5 or PM 10, one of them either PM 2.5 or PM 10. This is the correct statement as per the CPCB analysis, CPCB method of evaluating AQI. This statement 1 is true. Look at the statement 2. The AQI value, this is an MSQ question. The AQI value for a given location is equal to the maximum of subindices calculated for individual pollutants. The AQI value of a given location is the worst subindex of the pollutants given. Worst means maximum of subindices calculated for individual. Therefore, according to CPCB method of AQI, statement B is also true. Look at the C value. C statement, higher AQI values always indicate better air quality. Higher the value, worse the air quality, higher the value, poorer the air quality. Therefore, this statement is wrong statement. This is wrong. Look at the D. The subindices for the individual pollutants at a monitoring locations are calculated using its 24 hours average concentration value only. Look at the statement clearly. The statement is true up to this. The only is added in the statement, make the statement wrong. Okay, let me take a small time of yours to evaluate, to discuss about the air quality index by CPCB method. What is the document is saying, right? Look at this air quality index. Here, total 8 pollutants considered. It doesn't mean it not necessarily monitoring is needed for 8 pollutants. He is saying minimum 3 out of 1 should be either PM2.5 or PM10. We have taken a category, criteria pollutants are 8 only, right? But out of which need not to monitor all the 8 pollutants. If you have minimum 3 out of which 1 should be either PM2.5 or PM10 is sufficient to establish AQI, sufficient to report AQI of that particular city or particular location, right? Another important point is a minimum of 16 hours data is considered. If you are monitoring any of the pollutant in the city, minimum 16 hours monitoring is needed, right? This is what important point. Let me add one more point. It is also important point. You need to remember criteria pollutants in the Indian AQI framework. In Indian cities, we have a framework of 8 pollutants. What are those criteria pollutants? Very easy to remember. First, PM2.5. Let me take 1, 2, 3, 4, 5, 6, 7, 8. First one is particulate matter, PM2.5. Second one is PM10. Particulates are done. Now SOx, NOx. You can say sulfur dioxide, nitrogen dioxide. Another gases are carbon monoxide and ozone. All gases, particulates put together 6, right? Particulate gases. Now lastly we have, finally we have ammonia, NH3, and also lead. These are all pollutants, criteria pollutants in the Indian AQI framework. They may ask, SO2 and NO2 are considered as a criteria pollutants in the AQI Indian framework. You need to select those 2 are correct, okay? Remember, all the 8 pollutants we are considering in the AQI, and these points, necessary points, right? On these basis, most of the questions they are asking, okay? This is about AQI. Now, let's take this question. It's also easy question. The equivalent calcium carbonate concentration of 117 milligram per liter of NaCl is, what is asking? You need to express NaCl weight given as milligram per liter in terms of CaCO3, equivalent calcium carbonate. How to express this? Very easy, you all know. if the data is given for some pollutant weight, you can convert that into equivalent CaCO3. How to convert? The conversion is weight of any compound, not NaCl, weight, here NaCl needs to convert weight of NaCl by equivalent weight of NaCl, equivalent weight of NaCl, which gives milli equivalents of NaCl. Weight by equivalent weight is the first step. Multiply with equivalent weight of CaCO3. Here he wants to express the equivalent CaCO3 concentration of NaCl is asking. He needs to write equivalent weight of CaCO3. He has what is equivalent weight of NaCl? Equivalent weight of NaCl is very easy. He has given atomic weights. Equivalent weight of NaCl is how much? Equivalent weight of NaCl. What is the atomic weight of sodium? 23. Chlorine 35.5. Use the given data only to minimize the error. Okay, don't take 35. 35.5, take that. 58.5 is the atomic weight. Equivalent weight divided by valency. What is the valency? 1. Therefore equivalent weight is 58.5. Very easy, right? 58.5. Now what is the weight given? 117 divided by 58.5. You know equivalent weight of CaCO3 is 50. It means what is the answer? 100 milligram per liter as CaCO3. We converted in terms of calcium carbonate equivalent, right? 100 is the correct answer. Okay, 58.52, right? Simple question. See, one thing I'll try to give here. You can express equivalent of any compound. You need to multiply equivalent of that compound. If you ask about some NaHCO3, equivalent weight of that will convert that NaCl into NaHCO3. Any compound you can convert, not only CaCO3. Okay. Okay, next question. This is a MSQ question from quality of water. Look at this. As per Indian standard, the code is 10,500 and 2012. Indian Standard Code, Bureau of Indian Standards. Drinking water standards. Which statements is or are correct? Look at the statements given. Desirable limit of TDS is 500, right? TDS value is 500. The statement is correct. Permissible limit of fluoride is 1.5, also correct. Acceptable pH range is also correct, 6.5 to 8.5. Chromium permissible limit is 0.5. Here it is wrong. Chromium permissible limit is 0.05 milligram per liter. We have solved one question, right, earlier. First question. This is what wrong. You need to select 3 options. A correct, B correct and also C correct. 3 options you need to choose. Okay, easy question. Next, this is one of the typical question from air pollution chapter, but very easy. You need to very careful in taking the data given in the question. It seems to be lengthy, but you can easily answer. During rush hour on a busy road crossing, nearly 1200 vehicles ply per hour at an average speed of 20 km per hour. How many number of vehicles are moving in a busy road crossing? 1200. What is the average speed? 20 km per hour. Of these, out of 1200, 70% cars use leaded petrol. Out of 1200, 70% only uses leaded petrol, blended petrol, lead. Okay. The average fuel consumption is 1 liter for an average of 8 km of travel. It means mileage in our general terms, right? 1 liter of fuel, 8 kilometers you can travel, right? That is what mileage given. Considering the 70% of the lead present in the fuel is emitted in the form of particulate aerosol. Lead aerosol is emitting out of the total fuel. 70% of the lead present in the fuel is emitting. Total lead is not emitting as a aerosol. Only 70% of the lead is emitting. That is what given. The emission rate of the lead present in the ambient air is dash in microgram per hour. You need to be careful in which units he is expecting your answer. What he is expecting? The emission rate of lead aerosol in the ambient air is dash. That is in microgram per meter cube. Again he has given one important point at the end. Concentration of the lead in the fuel is 0.4 microgram per liter. In each liter lead presence is 0.4 microgram. Assume bright day with a light wind. that is what he is expecting. Now to solve this question, total number of vehicles are 1200, and let me take this question. See, total, I am just evaluating total distance in kilometer, total distance travelled by vehicles, total distance, okay. Those vehicles using leaded petrol I am concentrating, right. Okay, total is 1200 vehicles ply, each vehicle is travelling at 20 km per hour. Out of the total vehicles, 70% is leaded petrol, means whoever is using leaded petrol, those vehicles are travelling this much distance. Each vehicle is 12 km per hour, 1200 vehicles ply per hour. In an hour, how much distance the total vehicle travels? This is the distance. If you evaluate this, you will get the answer. Total distance 1200 into each vehicle 20 km per hour into 0.7. Why 0.7? 0.7 is like out of total only 70% are using leaded petrol. 16,800 is the total kilometer. You know the mileage, right? If you consume, if you have 1 liter petrol in your car, it gives 8 km of distance. It means if I need 1 km journey, how much fuel I need? 1 by 8 liter. 1 by 8 liter means 0.125 liter of petrol I need. What is the total distance covered by leaded petrol cars? 16,800. Therefore, total fuel, how much? Total fuel is each kilometer 0.125 liters, right? Each kilometer 0.125 liters, but total how much journey that overall vehicles are taking? 16,800 is the total journey into 0.125 will give you total amount of fuel. It means 2,100 liters of fuel I need, right? 2,100 liters. Now look at this. In each liter, what is the value of lead present? 0.4 microgram, right? He has given the concentration of lead. See, lead he has given equal to 0.4 microgram per liter. How many liters of petrol is consuming leaded petrol? 2,100. Therefore, total lead. What about total lead? Concentration is this. In each liter, 0.4 microgram is present. Therefore, total lead is equal to how much? 2,100 into 0.4 microgram per hour. This is all evaluated per hour only, right? In an hour, 1200 vehicle ply, each hour 20 km, 70 is leaded, total kilometers in an hour, total vehicles. Therefore, this is total lead in an hour into 0.4 will give you 840. This is 840 microgram per hour only. I am not indicating in each step hour. Okay, this is our total lead. Out of the total lead, you can use the statement again here. Somewhere he has mentioned, considering the 70% of the lead present in the fuel is emitted in the form of particulate aerosol. Out of the total lead, only 70% out of the total lead, not 840 microgram per hour is releasing, 70% is only releasing. Therefore, emission rate is equal to, out of total lead, only 70% means 0.7 is you need to take. 0.7 means 588. The answer is 588 microgram per hour. You are getting the exact answer, 588 microgram per hour. This is the correct answer, right? You need to enter 588 with your virtual keypad, right? This is also easy question. Don't miss any of the statement given. Sometimes you may, if you are in a hurry, you may take 840, that is the total lead is emitted, but emission rate is not that, it is the total lead, right? But out of the total, 70% is emitting into particulate aerosol, right? That is 588 correct. Okay, next question. This is also typical question. If you miss any of the statement given, you may miss the answer, right? This is a MSQ question. Look at this. An automobile exhaust emits 5 kg per hour of volatile organic compounds. It is emitting VOCs as a rate of 5 kg per hour. A bag filter placed over the process equipment captures a portion of the VOCs. The fugitive emission rate is given as 0.25. If the automobile operates for 8 hours per day, automobile is operating in 8 hours a day, not entire day. Okay, which statements is or are correct? Now he is saying if you can evaluate efficiency of the bag filter and also total VOCs produced in a day, your question is complete, right? First time evaluating efficiency of bag filter, right? See, emits is this, right? Exhaust, automobile exhaust is containing this, but your control equipment, bag filter you have placed over the process equipment captures some portion, but fugitive emission rate is how much? 0.25. What do you mean by fugitive? Fugitive means escape. No system is 100% accurate. Whatever the 5 kg cannot capture all 5 kg. 0.25 is escaping the system. That is what? Fugitive emission rate. If 5 is coming, 5 is entering into bag filter, 0.25 escaping the system. What is the efficiency of bag filter? The efficiency of the bag filter, efficiency of bag filter, I am writing the bag, is how much? 5 minus 0.25. This is what escape, right? Capturing is this divided by 5 into 100, you will get 95%, I think. Let me check. 4.75 divided by 5. 0.95 means into 100. Efficiency is 95%. Now another answer is, be careful with the option C and D. See, in is saying total VOC is produced in a day. Be careful with the wording. Look at this. The exhaust, automobile exhaust emits 5 kg per hour of volatile organic compounds, but total VOC is produced. See, fugitive emission you need not to take. What is asking? Total VOC is produced in a day, not after the capturing. Before, what is produced, right? That is what total VOC is produced. Produced means not a fugitive. Produced means what actually that automobile is emitting. That is how much? 5 kg. Therefore, total VOC is equal to, it actually emitting at 5 kg per hour into, what is the value you need to consider in a day? Automobile is operating 8 hours per day. Only 8 hours automobile is in operation. Therefore, this is 5 kg per hour into 8 hours in a day will give you how many? How much? 40 kg in a day, right? Total VOC produced. You need to select 95% bag filter efficiency as well as total VOC is produced as C. Therefore, which option is correct? B comma C. Easy question, but be careful with the wording. Produced means not fugitive emission. Okay. Next, this is an important area in a solid waste management. Some stoichiometric oxygen requirement is also important. Many of the previous year questions are based on the stoichiometric requirement of MSW. You please solve all of them. Okay. Let's take this similar different question here. A city generates these many kgs of MSW per year. Over a period of year, this generating rate, out of which only 10% is recovered and recycled and the rest will go to landfill. The landfill has a single lift of 3 meter. 3 meter has a lift height, 3 meter has a height and is compacted to a density as 550. Compacted density 550. 80% of the landfill is assumed to be MSW. The entire landfill is not only allocated for MSW, only 80% of landfill area is MSW. The landfill area up to 1 decimal place required would be dash. See, very easy question. If you can understand the logic here, what is the MSW generated? MSW, municipal solid waste generated is how much? Municipal solid waste generated equal to per year 40 into 10 to the power of 6, out of which 10% is recyclable. Therefore, landfill 0.9. 0.9 means 36 into 10 to the power of 6, correct? 40 into 0.9 will give you 36 into 10 to the power of 6 kg of MSW is moving to landfill site. Now this is the mass of MSW is moving, but we have a compacted density of MSW. What is the MSW's density? 550 kg per meter cube. If this is the density, you can easily guess what is the volume of MSW. Volume of MSW equal to 36 into 10 to the power of 6 divided by 550 will give you volume. This is kg per meter cube divided by 550 will give you volume. I got the volume 65445 meter cube. Please try to write up to 3 decimal for correctness of the answer in NAT. Okay, this is the volume I got. Now I have a lift of 3 meter, therefore what is the area? Area of the MSW? Area of municipal solid waste equal to volume of MSW. It has a single lift of 3 meter height, will give you area. Therefore I am substituting the earlier value in meter cube divided by 3 will give you, this is the area, 21,818.1818 meter square is the area. Now the logic is, he is not asking this area. Don't write why I am selecting this question is, don't write area. See, the landfill area up to 1 decimal place he asked. Don't enter this value as your answer. Why? Here he mentioned if 80% of the landfill is MSW. 80%, what you have evaluated is 80% of total area. You need to enter total landfill area, not MSW area, right? Therefore be careful. This is the MSW occupied area in the landfill. Now I want total landfill area. This area is nothing but 80% of landfill area. 80% of landfill. Now what is the landfill area now? Area of landfill is how much? Area of landfill equal to 21,818.1818 divided by 80% means 0.8. You will get the more area, right? Divided by 0.8 you will give 272.727 meter square is the area you need to enter. This is the correct answer, not this answer. Okay, total area is asking. This is the one of the easiest question, but be careful. Okay, next question. This is a bit easier, but be careful with the statements. All statements you need to read for MSQ, right? Look at this. With reference to ASP used for secondary wastewater treatment, which of the following statement is or are correct? If you look at the each statement, statement A is saying the process primarily removes organic matter through biological oxidation under aerobic conditions. ASP means what? It is a biological removal through aerobic conditions. Therefore, statement A is correct. It is in the same tone of ASP, technicality, right? Now, if you can look at the B, increasing sludge age generally enhances nitrification in the reactor. Increasing sludge age means mean cell residence time. If you increase MCRT, it favors the growth of nitrifying bacteria. If more residence time if you offer, it favors the growth of nitrifying bacteria. If nitrifying bacteria is growing in the reactor, what happens? Nitrification in the reactor enhances. Therefore, this C is also in the same tone of ASP, right? If you can look at this C, RAS, return activated sludge, is used to maintain the desired MLSS concentration in the aeration tank. This is also correct. That's what we do. Recirculation, that activated sludge recirculated, right? Whatever the secondary sludge we are having, we are taking that sludge to the aeration tank again, right, to have better efficiency of treatment, right. That is also correct. Now look at the option D. Higher F by M ratio always results in better effluent quality. Look at this higher F by M ratio. F by M value is higher means food is more for a limited microorganisms. If you offer more food to lesser number, what they usually take? They'll eat more, they don't do work, right. F by M ratio is higher means more food is there for a limited number of people, they keep eating, they forget about the task, right. More F by M ratio leads to poor quality of treatment, right. This is higher F by M ratio always results in better effluent quality. Better is wrong, therefore option D is wrong. Poor effluent quality, more BOD you can get in the effluent, also the efficiency of the reactor is also less. Lower F by M ratios only enhances your treatment. Therefore, which options are correct? You need to check, you need to take A, B and C also. 3 options are correct. This is about ASP. This is all about our environmental engineering questions. Before closing this session, let me take this important announcement for you. We are starting a revision series batch. This is the live batch. It starts from January 10th, 2026. This batch hardly takes 15 to 20 days of your time, and it helps the students to revise all the concepts in all the subjects, not only environmental. This batch is for all the GATE subjects, whatever the syllabus mentioned in your GATE, including maths, everything, will cover this syllabus in 15 to 20 days. You can get the some concession also, like if you apply GATE 26 as the coupon code, you will get 30% off for this series, revision series batch. This is an online mode, completely online, usually starts in the morning. They spend generally 5 to 6 hours a day. Whole 20 days you need to attend the sessions to complete, to revise this entire syllabus, right. Now hardly takes 15 days, 15 to 20 days, all the concepts and the questions are revised, okay. It will enhances your GATE score, okay. Please try to avail this offer, avail this series. But not the least, this is the GATE, pre-GATE we are conducting to experience the live performance while writing the GATE exam, right. Before writing you must have some practice, net practice kind of thing, right. It is on 18th of January. Please enroll to pre-GATE also, will enhances your score. All these 2 things will enhances your score, boost. Please use this courses through our ACE Academy website, okay. I wish you all the best for your GATE preparation. Thank you all.